challenge was to solve 2x equals 13 for x. Does anybody have that solution? Okay, if you do not understand that one, every single person should understand it at the end of class today. Okay, so this is what we're talking about today, how to solve and convert exponential functions to logarithms. Okay, so we're going to use logarithms to help us out with this. So this is our warm-up for today. I'm going to set that to the side, and we are going to do our intro to logarithms notes. So these notes should be pasted on Canvas, or not pasted, but posted or whatever on Canvas for you to print out if you would prefer. If you would like to just write it down on a sheet of paper, that is totally fine too. Okay, so this is our introduction to logarithms. All right, so the EQ for today is how can I rewrite the exponent as a logarithm and a logarithm as an exponent. Okay, so we're going to start with. So the first way we can solve problems like this, also logarithms are written as log, and they have a base of an x, and then they have some stuff on the inside. Okay, so that's what I mean by a logarithm. Okay, so back to our graphing. If we set y1 as our e to the x and y2 is ln x, okay, so I'm going to do this on Desmos so you guys can see, since I don't think most of you have graphing calculators. We're going to do it on here. So we have, let's see here. E is the base for our y1. And then we want to raise it to the x power. We should have e to the x here. Make it a little darker. Oh, that's still not very good. Let me turn my brightness down. Maybe that'll help. It's too dark. All right, and then in our second, we're going to type in the natural log of x. If you go to the little func button on the side, move this down. Then you can go to miscellaneous, and your little natural log ln should be right there. So again, you go to funcs, miscellaneous, and then the natural log is over here on the left side. Okay. So let me get out of here. Oops. Oh man. So funcs, miscellaneous, natural log, and then we're going to type in an x. All right. So we have our two functions here. All right. And what do you guys notice about these two graphs, this red and green graph? Does anybody see anything special about them?
They look the same. They're just sort of like flipped.
Exactly. They're the same, but they're flipped over the line y equals x. Okay, so they're flipped over this purple line right here. Very good, Katie. All right, so they are over y equals x. Does anybody remember what that means about the two functions? When two functions are reflected over the line y equals x, they have a special relationship. What's that relationship? Okay, we talked about this in Unit 1. It was a big topic we went over. Let's see, Jakeem. Do you remember when one function is reflected over y equals x, what is the other one? What's the relationship between those two functions?
Isn't it something like negative or something like that?
Not quite. It's an I. Anybody? Okay, so when two functions not intercept.
I'm just throwing that word.
That's okay. Good guess. All right. So when two functions are reflected over the line y equals x, it means they're inverses. So we understand that y equals the natural log of x is the inverse of y equals e to the x, okay? And this ln here means the natural log. Jakeem, I believe I marked you absent, so just make sure to stay after class and let me know that I need to mark you present. Okay. So this means that the base of the natural log is, okay, so now have the same base as an exponential function are gonna be inverses of each other, okay? If you see log written with no base, it is understood to be 10, and the base of the natural log is e. So that is the answer to this question here. Okay. All right, in part 2, we're going to talk about rewriting exponents as logarithms. So exponents and logarithms kind of have the same ingredients, but they're mixed together in different ways. Okay, so an exponential function is going to be written like this. We're going to have a base and an exponent equals some sort of answer. Okay, that's how an exponential function is written. Okay, now a logarithm is going to be written so we have a log with a base. The answer goes on the inside, and it's equal to our exponent. Okay, so this is the stuff for our logarithms. So I'm going to highlight these 3 different parts so that you guys can see how they're rearranged. So our base for our exponent is here, but our base for our logarithm is there. Our exponent goes up here. Our exponent goes on the right side of the equal sign for a logarithm. And then our answer for our logarithm is our answer on the right-hand side for our exponential function. Okay, so same ingredients rearranged. Rearranged. Okay, that's how exponents and logarithms work. Okay. Okay, so I'm going to do some highlighting in this first problem, and I'm going to model how switching to a logarithm would look for this function. Okay, so my base, I use this pink, and this is an exponential function, so my base is here. My exponent is here. That's blue. And then my purple is my answer, and that's here, this 3. Sorry, it's kind of dark. It should lighten up as it dries. Okay, so to rewrite as a logarithm, I write it as log. I want my base on the bottom, so I want my 2 down here. I want my answer on the inside, so I'm going to put my 3 right here, my purple part. And I'm going to set that equal to the exponent, which was my x. So I'm going to highlight the parts that were the same so that you guys can see how we rearranged it to be a logarithm instead of an exponent. Okay, now do you guys see how convenient this is? Instead of having to ask the question, 2 to what power gives me 3? Now I have an equation where x is isolated, and I can type this into my calculator to figure out what that value is. So if you're using Desmos, okay, and it doesn't ask you to do this, but if you're using Desmos, oh, come on, go away. Go away, go away. We can type in, let's see, I want my logarithm with a certain base. My base is going to be 2. I'm going to type 3 in here, and it gives me my value down there. Let me turn my brightness down again. Okay, so you can see this answer right here. All right, let me close that off. So my answer is 1.585 for this particular value. So that's going to be my x value. This doesn't ask you to actually solve for x, but that's why we're doing all of this. Our goal is to solve for x. And so we sometimes have to rearrange our exponential functions so they look like logarithms. All right, what questions do you guys have on that very first one? Okay, if there are no questions, then we're going to go ahead and start on number 2, and I'm going to start calling on you guys to help me out since I've modeled one for you. Okay, so Jarrell, are you here? Lamero.
Yeah.
Okay, so can you identify the base, the exponent, and the answer for me in number 2?
Okay, the base is 3.
Perfect.
The exponent is 2.
Perfect.
And the answer is 9.
Perfect. So how am I going to rewrite this as a logarithm?
You're going to put 2 down there. Or not 2, 3.
What's my base?
You're going to put the answer in parentheses.
Yeah, which was what?
9 equals, what was it? 2?
Yeah, it's kind of blurred out now.
For the,
Sorry. Good job. Okay, so I'm going to go ahead and highlight these values so you guys can see how Lamero perfectly converted between a logarithm and an exponent. Okay, there's our 9, there's our 2. Brighten this up a little bit so the highlighting doesn't impede the numbers so much. Okay, great job, Lamero. Very good. All right, let's do number 3. Henry, are you there?
Yeah.
All right, so what's my base for number 3?
4.
Perfect. What is my exponent?
-2.
Perfect. And what is my answer?
1/16.
Perfect. Okay, so I'm going to rewrite this as a logarithm. All right, how do I rewrite as a logarithm?
You multiple log.
Yep. What's my base?
And then 4 as like. Yeah.
Yep, as the base.
And then you put -8 in parentheses, or no?
What?
1/16 in parentheses, right?
Perfect. Yeah, 1. And it's going to be equal to what?
And now the -2 equals -2.
Very good. Perfect, Henry. Good job. It sounds like somebody's trying to get in, so let me let them in. All right. Okay, so I'm going to highlight our pieces so you guys can see how we rearrange. All right. Here's our purple and our blue. All right. Great work, guys. All right, and I'm going to do the very last one for you guys since it's almost 1 o'clock already. All right, so my base here is E. Okay, my exponent here is X. And my answer is 45. All right, so now I'm going to rewrite this as my logarithm. Now this is an exponential function with a base E. So it's going to be log base E, but we abbreviate that LN. Okay, so I'll write it both ways. So this is log base E of 45 equals X, but you could really just write LN of 45 equals X. Okay, so when we write that